Okay, let's talk about what graphs should look like when you're working on absolute value inequalities. So let's look, an absolute value inequality, it has the bars for absolute value, and it might say like x plus 2 and then greater than 5, or some, that's just an example. Okay, it's got an absolute value, it's got a greater than, or maybe a less than sign. Now, sometimes when you work these, your answers are and, sometimes they're or. How do you know? If the problem starts out as less than or equal to, it's going to be an and statement, and it's going to be there's going to be one part to the graph, one piece. Now the way you can remember this is if you read that symbol as a less than. Don't say less than, say less than. Then it's going to be an and statement. Now, if the original problem starts out as greater than or equal to, then it's going to be an or statement. And that means it's going to be this or that. So it's going to have two parts to the answer. Okay? So the way you can remember this, it's instead of saying greater than, say greater. Now, if I were an artist, of which I'm not, one of my students told me one time that if you look at a rowboat from the top of the boat, the oars in the boat are how you row a boat. That's how you make it move. The oars always point out of the boat. So when he was thinking about the graphs, he equated them to the oars in a boat. And that'll make a little bit more sense when we get down here and start looking at graphs. Okay, now we've got 4 types of graphs. The first 2, they each have endpoints, and there's only one piece in the graph. It's connected. The other 2 have endpoints, but they each have 2 arrows. So the first one, this is an and statement. Okay, this graph shows all the numbers that are greater than 4, greater than or equal to 4, and at the same time, they're less than or equal to 9. They meet 2 criteria. So this is an and graph. Now, because the endpoints are colored in, then it's going to be a less than or equal to, because the endpoints are colored in. On this next one, it's one piece, so it's an and. But notice how the endpoints are open. They're not colored in. They're just circles. So this one is just less than. This one is less than or equal to. Less than or equal. And this one is just less than. It's an and graph. Now, we're down to our boat. See how this is, the oars are pointing out of the boat? If there were an imaginary boat right here, okay, the oars are pointing out of the boat. So, this is a greater, so it's an or. And it's either going to be greater than, or it's going to be greater than or equal to. So, how can you tell? Greater. The endpoints are colored in, or closed is the term they use. So it's going to be equal to, greater than or equal to. And this last one is or, like the oars of a boat are pointing out. So it's greater, but since the endpoints are not colored in, it does not get that equal to sign. So that's working from a graph backwards. Now let's look at how do you write the answers to these. So just because you can pick out a graph doesn't mean you know what the answer should be. So you have 2 ways to write it. You can write it as an inequality that has the greater than, less than symbols, or you can write it as an interval that has like brackets or parentheses. So first of all, let's figure out, this one is an and, okay? It's all one piece. So what we're going to do is we are going to start with the lower number 4, and all the values that make it true, we're going to call those x's, less than x less than 9. If you start with the lower number, you're going to use less than, because the lower number is lower than the other number. Now, because these endpoints are colored in, I need to put less than or equal to on here. That is called inequality notation. Now, I prefer interval notation because it's shorter. This one starts at 4 and it goes up to 9. And I'm putting the square brackets because the circle is colored in. If it's not colored in, you're using a parenthesis. So let's look at the next one. We're going to go from 4 to 9, but this time I'm not going to use the equal to because the endpoints are not colored in. And when I come to interval notation, I'm going to use open parentheses because the endpoints are not colored in. That means everything all the way up to 9, but don't count 9. Count 8.99999, but the actual number 9 will not make a true statement. All right, let's look at this one. We got the oars of the boat pointing out. So this is an or problem. So that means we're going to have 2 parts to our answer. There are 2 parts to the graph. So there are 2 parts to the answer. So let's start with the lower one. This arrow back here starts, it does not stop. It goes all the way back to negative infinity. And then it comes up here to 4. Now over here, this one starts at 9, and then it goes all the way to positive infinity. So, because it's an or statement, I'm going to start with the lower end. It goes from negative infinity up to 4. Look, I used a parenthesis and a bracket. I can never get to negative infinity. Okay, you'll never get there. It will never be equal to negative infinity, so that's why you use a parenthesis. Infinity always gets a parenthesis. Because this endpoint right here with the 4 is colored in, it gets a square bracket. And then I write the word or you might see the symbol union. That means or. From 9 to positive infinity. Now, for a value in this graph to be true, it either has to be in this section down here or in this section up here. There's 2 parts that it could be to make a true statement. Now, wouldn't it have been nice if I would have put that in the right spot? Interval notation is over here. I got a little ahead of myself there. My infinities don't look very good either. Remember, you might see a union symbol right there. How about if over here we do inequalities? So, the inequality says from negative infinity all the way up to 4. That means all the numbers that are less than 4. So, x is less than 4, or then these are all the numbers that are greater than 9. X is greater than 9. But since the endpoints are colored in, I need to put the lines for the equal to under there. This is the inequality notation first, and then the interval notation. Alright, so this one's going to be very similar. It's going to be x is less than 4, but no underline, because it doesn't have a circle on it. Or x is greater than 9. No underline because it's an open circle. Over here, we're still going from negative infinity up to 4, but I'm not going to make it square. I'm going to do a parenthesis since it's an open circle, And like I said, you might see the union symbol or you might see the word or. You got to get used to different books, different tests, different publishers. They use different symbols. It'd be a lot easier if everybody used the same symbols, but it's not. Okay, so let's work backwards here. Test taking skills. You're looking at a quiz. You have no clue how to answer the question. All right, so I am going to quickly recreate these graphs. I wish I would have had one more copy of that. So it could be one piece with connected endpoints. It could be closed endpoints. It could be one piece with open endpoints. It could be oars pointing out of a boat with closed endpoints. Or it could be oars pointing out of a boat with open endpoints. Now, I did not draw the number lines, but you get the idea here. So, you're looking at a quiz. You've got no idea what the answers are, but you want to make a remotely educated guess. So let's figure out how we can do some process of elimination. Let's look at this symbol. It's a greater than. So, is there a line underneath it? No. So that means the endpoint is not going to be colored in. So it could be this one or this one because the endpoints aren't colored in. Well, it has a greater than. Remember that's greater. So it's an or problem. Which one of these has the oars coming out of the boat? This one down here. So it's an or with open endpoints. All right, let's look at this next one. This one is a less than. Again, it doesn't have the line under it, so it's got open endpoints. Well, we already know it's going to be this one, but let's pretend like we did not have this one already used. So, it's going to be a less than, and remember the graph of and is one piece, so we're looking for a one-piece graph with open endpoints. That would be this one. I'm just trying to teach you how to use some skills to narrow down the answers so that if you're taking an ACT and you're clueless, you can quickly make a decent guess. Alright, so this next one, we got less than or equal to. Now right away, I hope you're saying, oh, that one's got an equal to, so it's got to have colored in circles. Well, those are the only two options left, so yes. Then it's less than. So it's less than. It's an and graph, and an and graph is all one piece. So you're looking for a one-piece graph with endpoints colored in. So that would be this one. And then for the last one, let's see if this purple works. This is greater than or equal to. So it's a greater. It's an or problem. We got oars pointing out of the boat. Two pieces. You got to have two oars or else you're just going to be rowing in a circle. And it's got an equal to, so you want them pointing out and you want the endpoints colored in. So that's going to be this one. So when you're looking at a quiz, even if you're totally clueless on how to solve it, you can narrow it down. Okay, and then, now you're not always going to have only these four options. So you do have to know how to actually solve the inequality, but this will at least, it will help you narrow down your choices.